Let's calculate the derivative of the square root of x, y equals the square root of x, using the definition or the difference quotient. So remember, just a reminder, there's the definition of a derivative, or one of the definitions of a derivative. So let's write it out. The limit as h goes to 0 of f of x plus h, which is the square root of x plus h for our example, minus the square root of x, which is f of x, all divided by h. That's the easy part. The hard part is simplifying that. So here's the trick. When you have quadratics like this, we use what's called the conjugate a lot of times. So the conjugate is the square root of x plus h plus the square root of x. I just take this thing right here and I flip the sign in the middle. And of course, I can't just multiply that on the top. I also have to multiply it on the bottom. So that's what I'm doing. I'm multiplying this fraction by that. And when I do, I get the limit as h goes to 0 of what's going to happen here is those are going to cancel out. The square root symbols are going to cancel out. So you're just going to have x plus h, right? Because x plus h squared, the square root of x plus h quantity squared, they'll cancel out, the square root and the square. These middle terms, that's why I did the plus there, the outside and the inside of the FOIL process will cancel each other out. That's why I picked that. And then these last terms are going to be negative x. It just square root of x squared is just x, right? But it's a negative because it's a negative times a positive. Okay? And on the bottom, here's the thing. You don't really have to worry about simplifying that. Just write h and then write that big old mess in with it. That's all you got to do. Now look at how beautiful this is. What happens to the x and the negative x?
They cancel.
Yeah, they cancel. They're gone. So you really just have the limit as h goes to 0 of h over h times the square root of x plus h plus the square root of x. And now what happens to the x's? They cancel too. So you really just have the limit as h goes to 0 of 1 over the square root of x plus h times plus the square root of x. And now I can plug the 0 in. I couldn't plug 0 in at the beginning because that would have a 0 in the denominator, but I can plug it in here and I'll just get 1 over the square root of x plus the square root of x, which is just 1 over 2 square roots of x. And that's your answer.